We're so happy to have you all join us with our panel today. I'll actually just come down here. So today's panel is called Build a Connected Supercomputer in the Sky. The format of today's presentation is going to be a little bit different. It's actually a birds of a feather, and we'll get to that later. But let me introduce the panel first, if it connects. Or I'll just come over here. Okay, so I'm Lauren, and then we have Chad Sweet. Say hi. You can say like what you are. Okay, Chad is the CEO and co-founder of ModalAI. We have Eric all the way at the bottom. He is the chief of software at ModalAI. James Strawson, lead roboticist, and we are joined by Andrew Wilkins, CEO and co-founder of Ascend Engineering. Okay. So as I mentioned before, today's panel is going to be a birds of a feather session. So for those of you who aren't familiar with birds of a feather, it's kind of like a discussion with the audience, Socratic seminar style if you remember from college. Our three goals today are to discuss advanced autopilots and open source, share best practices for enabling autonomy, and to brainstorm how our current technology and open source applications can be improved later on. So we definitely recommend that we have audience participation. Raise your hand. I'll come over with the mic. So yeah, let's go ahead and get started. So the topic is how to build a connected supercomputer in the sky. So let's start with connectivity first. With a show of hands, has anyone built a connected drone before or used cellular? Yes? Awesome. Nice. And does anyone want to share how that experience was, and are you working on 4G or 5G, for example? Anyone do 5G at all? No? No one? Oh, Eric, you have? Okay, Eric, can you tell us a little bit about that experience with 5G?
Hello? Yeah, so I'd definitely like to get feedback from anybody who's done any work with cellular. In ModalAI, we work with a lot of different customers, and they've had all kinds of different reasons why cellular is interesting to them. There's clear cases like drone delivery where you're beyond visual line of sight, but you're typically in an area where there's going to be a lot of cellular coverage. And so having your network, your wireless connection to the drone go through cellular actually makes a whole lot of sense for that particular kind of market. But we've seen all kinds of other kinds of interesting use cases as well. And one of the other kinds of interesting things we've done is people who are considering using cellular for drones, but they're not sure if the area they're in has the correct kind of coverage. One thing we've done for a couple of different customers is actually fly around with some other kinds of wireless communication, but we monitor the cellular system. We log all the data, and we tell them this is what it looks like up in the sky in the kind of the areas that you're interested in flying in. So it's more of sort of a cellular monitor to kind of give them that feedback to tell them, yes, cellular is good for you or not. And a lot of this has been with 3G and 4G. Obviously now we have 5G, and we have a 5G enabled drone. And so you can have access to some sort of new capabilities in the cellular system. But definitely, yeah, we'd like to hear what people are interested in. What do they think that cellular is good for on a drone in robotics? Because we kind of spun out of Qualcomm. We have a lot of experience with cellular, and we're always really want to hear what people want to do with it.
Yeah, so is anyone working on any cool cellular projects that they'd like to share about? We're ready to have any discussion. Or if not, Andrew, you do Ascend Engineering, which is a drone consultancy firm. So do you have any clients who are currently working on cellular, and what are some of the pain points that they're experiencing? How do you help them with that?
Absolutely. So cellular, in my opinion, and in the firm's decision, is kind of like the main way going forward about how these drones are going to turn into supercomputers of the sky. You have onboard video, FPV, that you need relaying to the FAA, to all stakeholders that are interested in what these drones are doing in the sky, as well as telemetry data that you need to log to back-end databases things that radios right now, I don't think are going to be able to do at scale. And that's what we're seeing in our clients as well. So this large bandwidth of data that's transferring from these drones to back-end computers, to people who care about the video streams, to the people who are sitting in their offices who want to see how that inspection is going. ModalAI and the Voxel 2 does a great job at processing that onboard data, but that is going to be needed to be relayed to back-end systems as well. And that's what we're seeing from our clients. And especially too, I don't know if anybody's tried to drop down one of their radio connected drones behind a building at half a mile away, but the connectivity with 2 radios isn't great at that stage.
Yeah, absolutely. Chad, you spent a lot of time working on cellular at Qualcomm. Do you have any comments on this?
Well, yeah, sure. So to echo kind of, I think what Eric was alluding to on why would you go monitor some of the cellular connectivity, if folks are trying to achieve some level of FAA certification, what they're really interested in, what the FAA is really trying to ascertain is that you can achieve 100% reliable flight, or 99.99999% reliable flight. And so what they look for, if anybody, has anybody tried to go get some kind of FAA waiver or FAA? Yeah, okay. So what they want is data, and they want you to show reams and reams of data over and over and over that say, we were connected the whole time, or we were connected, we only had this many seconds of dropout during the period. And so we have had a number of customers, and we've worked with a number of folks that are literally just going out, flying, doing these surveys, and finding that really you are very well connected. And so on the Qualcomm front, we had partnered with AT&T at the time. This was like 5 or 6 years ago, and put forth really the first industry's white paper on this topic. And what it showed was actually when you get up in the air, your coverage is too good, and you actually become a detriment to the users on the ground. And so, which was kind of an interesting phenomenon. Everybody assumed that you wouldn't have coverage in the air. It turns out, due to RF, free space propagation, you actually have tremendous coverage. But the flip side of that is all of the base stations in the whole city can see your aircraft blasting its signal very loudly. So then we worked and actually worked with whoever their infrastructure provider was at the time, and on mitigating aspects, so where the network actually tries to determine whether you're an aerial vehicle, and then will actually turn down some of your parameters.
Yeah, absolutely. So in terms of cellular, has anyone run into any issues with creating cellular connectivity on their drones or devices thus far? Do you want to share about your experience? Maybe we can learn from each other. I'll choose you, Zachary.
Yeah, we've run into a lot of issues with programming with an LTE stick that's behind a NAT. For everyone that doesn't know what a NAT is, it's basically kind of like a wall that is made by these service providers that kind of swaps ports. So if you want to SSH into a device to program on the fly, you don't really have that ability. So there's a handful of things that you can do, but all of them are pretty time intensive and not very fun. So I was kind of wondering if the panel could tell me if they've ever experienced something like this, or if they can mess around.
Yeah, Eric's really the expert at that.
Okay, yeah, so I think if you look at like your Wi-Fi network in your home, it's a similar kind of a concept where you look at the IP address that a device gets in your home, and it's like a 192.168 something, and the only way things can get back to you is through some tricks in the router, the NAT, like you were talking about. And so it's not a publicly routable IP address. So a similar thing happens when you connect to whatever, AT&T or Verizon or whatever. If you look at the actual IP address that you get, that's not a publicly routable address. And so if you have that and you're running a video server on your drone that's got this address, somebody out in the internet can't just go connect directly to that IP address. There's no way for them to get to it. So what do you do? How do you make it so that you can connect directly to that drone and get the video off of it? So what we use at ModalAI is basically just an open source solution. It's OpenVPN. We take that and we, using Google Cloud servers, we run a OpenVPN server there. provision the drone, provision the ground station, have their certificates on there so that they can connect into the open VPN. And then once they're, everybody that wants to connect to each other is all on this open VPN, then they all have direct access to each other. And they can get VPN addresses then that they can talk directly to each other. One of our very first demos once we started ModalAI was where we were there in the office and many miles away at the flying field. Another one of our colleagues had the drone out there, turned everything on, it all connected, set up the VPN, and then running Q ground control in the office many miles away, I was able to set up a mission on the map, say start mission. We had our colleague there with the sticks just in case something went horribly wrong and he had to take over in manual control, but luckily everything was fine, and it flew the mission. And we posted a video of that, but that's basically how we did it, is using OpenVPN. So that's two of the biggest complaints with cellular is, one, how do I get around this issue? But the other is, how do I get service and how do I get a SIM and how do I put that in and how do I provision things? So yeah, there's there's some drawbacks, but a lot of pros on using cellular.
And then to add to that, some of our friends at T-Mobile have told us this, and we have not yet validated it, but there's a couple of ifs. If you use a 5G standalone network and you are on IPv6, you will get your own globally routable IP address. So the future looks good. There's a couple of ifs there, like the world is definitely not all on 5G, standalone systems and so forth, but an IPv6, is still not that well deployed. But if you follow a couple of ifs, it will all be solved. So hopefully in the next few years, some of that issue goes away.
You could also just get a static IP from like T-Mobile, but I wouldn't use ngrok or any other reverse SSH. That gets complicated quick, especially if you want to open up some ports.
Mm-hmm. Chad, you talked upon 5G, and I remember I asked the audience if anyone was developing, and I don't think anyone was, right? Unless you are, correct? So I would love to know, Chad, what 5G modems are out there and available for us to use now and to start implementing into our drones, and have you experienced any performance differences that you can talk upon with 4G versus 5G?
Yeah, so fortunately, there are much quicker than there were for 4G, but there are 5G modems that are available. We use a Quectel one that's in our current system. In the near term, as soon as we get through some of our backlog, we'll have Telit and Sierra supported as well. But some of the big advantages having to do with IP networking, because there's just a quicker response with lower latency, the video starts to just perform better, period. Even without really hitting any of those bandwidth. 5G obviously offers like this idea that you can get to gigabit speeds, but without achieving that, just the lower latency helps the our TSP protocols and the networking protocols behave better, and the video gets to be better quality more quickly. As the spec evolves, or really the spec actually has supported mission critical since very early on, but as some of these features get more broadly deployed, there will be just in general better latency, where the goal is like sub-millisecond, at least from the modem to the tower. You still have your backhaul issues, but a much lower latency for what you could think of as like real-time command and control. We fly real-time with sticks over 5G, but I'd say like that's not really what it would be used for. It's back to more, monitoring a fleet and maybe monitoring some light video. But it does work, but in the future it is intended to work, like falling into like what you might do with a self-driving car, right? It's like if you're not, maybe you're at level 4 and you're not quite at level 5, what happens when you fall back? The idea is like, ideally on a 5G network, somebody in a control center could take over that car and guide it to safety.
Got you, absolutely.
But that's not, I wouldn't do that. That's the hope.
Yes. Any other thoughts or comments from the audience about connectivity with drones or flying over 4G at all? Yes? Okay. And your name is Mike. Nice to meet you.
Hi, Mike, Workhorse Aerospace. Hello. We've been having really good luck with 4G. We've been using it for a couple of years. We do have a backup system as well. We do package delivery drones. A question for the panel. We've been very happy with 4G. It's worked great. I think in the past year we've had one issue, and it turned out it was actually a problem with one of the Verizon cell towers, we found out. So, but with 5G, is there, I think one of our reluctance to really look at 5G is the fact that while they say there's 5G everywhere, there really isn't. And we're concerned about, and I'm not a software person, sorry, but is there a concern with the fact that your 5G modem hooks up, but the service says it's 5G, it's not, it's actually something slightly different, enhanced 4G, whatever you want to call it. Have you guys run into any issues with that? Is it a concern?
I would say that's accurate, that that's what will happen, is there's probably a lot of really enhanced 4G or 4G plus versus pure 5G, but unless you were designing to fully rely on it, I don't think it would truly be an issue. It handles the fallback incredibly gracefully. And one thing on Lauren asked about 5G modems, one thing that's actually very interesting about the first generation of these 5G modems, these IoT modems, is they're all world mode. They all support like, I don't know how many, like dozens of bands, which is way easier for our 4G stuff that we work on. We've got, one flavor for Europe, one flavor for Australia, one flavor for the US. The 5G stuff is just one modem and they can go anywhere in the world. So from that perspective, it's actually, a little bit easier to deploy and more robust. But it's fair to say that, yeah, true 5G is certainly not ubiquitous, and that definition is nebulous, but that's always been the case. In terms of what 3G meant, what 4G meant, what 5G meant, it's really just the next G. But
Yeah, I'd also like to say we've flown drones over 4G, and having like manual control, and there's, you move over the joystick and the drone responds just fine, especially too with like an RTSP stream going. So like having live video and live kind of drone control has never been an issue over 4G. That 5G, once we get to that point, I think will be fantastic because then you can put more through the network. But even on 4G right now, when it falls back, it's not like your drone's going to fall out of the air. You give a manual input and then like 15 seconds later it moves. 4G right now is good for video streams and control over the drone. Telemetry.
Awesome. Okay, so now that we got connectivity out of the way, let's talk about performance and how to make our drones a supercomputer and how to achieve all of that. One of the things that I love in technology is the idea of Moore's Law, where as time goes on, big, huge technology that's not as capable gets smaller and smaller, but way more capable. My favorite example of this is how phones used to be huge and clunky, and now we have iPhones that fit into our pockets that are super thin. Chad, do you have any examples of this, in the drone industry, and how you've seen the technology become more and more dense as time goes on?
well, yeah, absolutely. So when I started working on this, one of that was exactly the value proposition, where it was, you've got this phone, it has all these capabilities, you've taken all these big cellular companies have put all this effort into densifying or condensing these capabilities, and now you can do it in this small single package. And I'd say, really that's just, as each evolution moves forward, we just continue to add more compute power, and it's now at the point of, we're demonstrating, or well, maybe the demo's put away now, but we were demonstrating 5 neural networks running concurrently, and things that just wouldn't even be feasible in an embedded package just a few years ago are now, I don't want to say commoditized, but they're out there and people are doing it, and it's very accessible.
Yeah, and James, as our resident computer vision expert, what are you working on at ModalAI that's pretty cool that you would want to share with the audience of this supercomputer type technology?
So I'll actually start by continuing the path Chad was going down, which is, I remember starting to play with drones a decade ago, and this was a time where even the lowest compute power drones were still big hex and octocopters just to get the PCBs up in the air. Everything's just been getting smaller and smaller since then. If you look through most research papers that have been published on autonomous path planning, mapping, and navigation, it's usually stuff that's been post-processed offline on a desktop computer, and then for the last video that they need to put up on YouTube or make the video for the conference, they'll put an Intel NUC on a really big octocopter and fly it around to say, okay, look, it can run real-time on a drone. Yeah, no. But now we're kind of at that point, and so that really lets us be lazy in some ways through the development cycle, and prove things out and test them without needing to do the extra work of highly optimizing the algorithms. So your cell phone now will load up apps 50 times faster than the Nexus 1 first Android phone did a decade ago. And it's not because the ARM core is 50 times the clock speed. It's not running at 200 gigahertz. It's that all of the most reused instructions and core components of the algorithms that run on your phone have now been optimized in the hardware, in the silicon. But that takes years and years of evolution to get there. You need to know what the algorithms are in the first place and prove them out before you invest billions of dollars in silicon. And so when it comes to 3D mapping and path planning, which is what I like to spend most of my time playing with, now we're at the point where we can prove these things out before going down the 2 or 3 year path of looking to make custom hardware or re-optimizing algorithms for the hardware that's available. So in a way, having the extra compute power lets us be a bit lazy and try things out and not have to try that hard to see what we like. And then obviously for the sake of battery life and flight time and cost, you still go through the process of optimizing. But now we can prove things out much more quickly.
Absolutely. Thank you for sharing that. And in the panel, we want to know from you, what cool computer vision techniques are you working on, or are you using any good architecture that is allowing you to enable great AI and great CV that you would like to share? Anyone? What projects are you working on, basically? We'd like to know. Or Andrew, rather, do you want to share anything that your customers are working on?
Of course I can.
Yes, let us know.
So the main thing that our clients look to the Voxel 2 to do is image recognition and obstacle avoidance, collision avoidance, which from a software standpoint, when we got the Voxel products, as we started on the first Voxel, out of the box, it looks intimidating because you just have like the board, right? Until you integrate into the drone, you had all your 3D prints and stuff like that. But from a software standpoint as well, it's actually ridiculously easy to set up from a software standpoint, somebody who's in that world. And so our clients have been asking, like, can it do image recognition? Can it recognize a human, a coffee, like just simple stuff like that to do their demos with while this thing is flying around and you can see it in real time, which is really cool. And then now you say, okay, well, what do we want this drone to do? Let's load up our own models on there and start playing around with that type of image recognition, which, sure, if you're a governmental type, you get those people that are like, oh, I want to use it to recognize tanks or whatever. Or some people that, they want to use it to recognize people as it's flying through to make sure it doesn't run into them. And so that and collision and obstacle avoidance to make sure that they don't crash their drones either, because some of these drones, 10 to 15K a pop, that's an expensive crash. So, yeah.
Thank you. Oh, you have a question? Yeah, please.
One of the techniques that we talked to about a year ago, we had a guest speaker on hemp. And hemp has a plant where if there's a male hemp plant, it will interfere with the female. And so, using a technology that goes around and actually identifies that male plant, I think it's a male plant, not a female plant, right, Dawn? Yeah. So that they can actually have the farmer or the rancher go out there and as opposed to walking the whole field and just looking for that one male plant, that the drone can actually identify that. And I was thinking that would be a great example. I know that you were talking about identifying a person or a tank. This is another technique of being able to utilize that technology. That's all. I just wanted to add to
absolutely.
That.
And we tried to bring beer in to encourage folks to ask questions. But maybe we should have brought a hemp demo, and that would have encouraged people to ask questions. But yeah, we do have a customer over in the Netherlands, Corvus Drones, and I don't think they're doing hemp. I don't know what they're doing, but they're doing greenhouse. I don't know what they're scanning for, but that exact same use case. They're doing crop, indoor greenhouse, crop analysis and inspection, and then for improving crop yield and so forth. But that's a good one. Which one's hard to find, the male or the female?
The male.
The male.
That's the one that it overproduces or it causes the females to seed. They don't want it to go into the seed. They want it to stay premature. So that,
All right.
good grass.
Excellent.
But that was just an idea, that we tend to limit our ideas, and this is kind of thinking out of the box, but this is really great technology.
Absolutely.
That really helps.
Thank you. Yeah.
Okay, I got a quick question. I'm going to apologize before asking this question because it's really more of a business question, but I couldn't think of a better session to ask it in. So, and this is the supercompute session. So we're all facing some amount of volume challenges in being able to get our navigation and our compute chips for the drones. And mostly the drone industry hasn't really had its own, supply chain for, advanced processors that are ideal. We really borrow and beg from other industries, communications with Qualcomm, automotive, and, automotive car industry, mostly with NXP and a variety of industries with like suppliers like TI and stuff. So, we're seeing that the supply chain is really looking miserable for anything M7 and above on ARMS. And so I'm curious as to what your strategies or what you would recommend for people that are doing advanced drones to be able to build them in volume with advanced processors as we face these supply chain issues. Do you think, I'll be more pointed, do you think that the communications chips from Qualcomm and those sources are more immune to supply chain issues versus like automotive chips or some of the system chips like analog chips that TI would sell? What do you think is the best strategy here for us suppliers?
Well, yeah, so to your first question, let us solve the problem for you, and that's what we do. we put advanced chips on PCBs and integrate them with flight controllers and make them available. So let us solve that problem for you. But in terms of, broadly, it's funny, every panel seems to talk about supply chain. So but it's actually not, the more advanced the process node, the easier they are to get, because that's where the most investment's going into now. Actually, the problem with the stop and start of the supply chain on the automotive stuff had to do with process nodes. A lot of those older parts on like 120 nanometer versus, the bleeding edge is on 4 or 5. I think the chip we're using here is on 7 nanometer, versus 120 nanometer. Nobody's going to build a 120 nanometer fab, period. So it's just not worth the time. So the problem was when they stopped those, or they shut those down for the pandemic, and then the demand picked up before they could accelerate that back. It's the fact that nobody's making an investment in that, but nobody's making an investment in fabricating those chips, that silicon. But of course, everybody's designed all those parts in because those were promised at $2 or $4, and they're very useful. Just because they're on an old technology doesn't make them not useful. They're very useful, and so that's why you hear this about it as an automotive problem. And of course, in the aerial vehicles, we use a lot of the same chips as automotive, and so it's way harder for us to build an ESC than it is for us to build a Snapdragon PCB. That's just the way it is. But again, let us or Hollybro or Robotics, let us solve those problems for you.
Yes. And just to keep us on.
We make our own boards, these PCBs. Yeah. We do not make the chips. No, this is on our board here, this is a Qualcomm QRB 5165, which. No.
And that's a great segue. Just to keep us going on track with time, just to be respectful of everyone's time, we did launch a new product earlier this year called Voxel 2. It is the Blue UAS Framework 2.0 Autopilot that does use the new Qualcomm QRB5165 that we have on display at our booth at G5, and we would love to just show you this quick little video introducing Voxel 2 to you all. And of course, the volume is not working, but but this is Voxel 2. It is a 16-gram PCB that runs on the Qualcomm QRB5165. It has up to 15 TOPS of AI computing, runs with PX4, and has up to 7 concurrent image sensors. So as you can see, it goes through the video and kind of shows how it enables smaller, smarter, and safer drones. And I apologize for not having the music, but it's showing the 5 neural networks that we are demoing outside, so we would love for you to come by and take a look at it. It is 16 grams and can enable small drones. This is an example of a reference drone that we have coming up soon, so follow us at ModalAI, and you can keep track of that. And it is very smart with GPS-denied navigation, obstacle avoidance, object detection, and mapping. If you came to James' session earlier today, he kind of explained how we use computer vision for safe mapping. And we're very proud. It is a Blue UAS Framework 2.0 Autopilot, which means that it's assembled in the USA and NDAA 20 compliant. Yeah, absolutely. And then this is like the last little section with depth mapping, with VIO, VOA, and it is 5G compatible. Okay, and that's Voxel 2. So thank you all so much for coming to our panel. We're going to be out there all day today and tomorrow, so thank you all so much. Awesome, thank you. And then make sure to come to Andrew's presentation tomorrow at 4:45, How Not to Bankrupt Your PX4 Project in Lone Star C. So thank you.